Hey everyone, welcome back to Age and Education channel. Today we shall look into the chapter Combustion and Flame, right? So what is combustion? Here first of all in this slide we shall look as what is the meaning of combustion and what are the combustible substances, right? So what is combustion? Combustion is a chemical process in which a substance reacts with oxygen to release heat. So what is it? It is a chemical process in which one substance that reacts with oxygen, and what it gives? It releases the heat, right? So in many cases, apart from the heat, light is also produced, right? Either in the form of a flame or a glow. So combustion is a chemical process in which a substance reacts with oxygen to release heat, and apart from heat, in many cases light is also produced during this process, either in the form of flame or a glow. Substances that undergo combustion are called as combustible substances, and they are also referred to as fuels, right? So combustible substances are also called as fuels, and the substances that we have talked about here in the process of combustion are called as the combustible substances, right? And fuels can exist in solid, liquid or gaseous forms. For example, charcoal is a solid fuel, petrol is a liquid fuel, and LPG is a gaseous fuel, right? So, air, or more specifically the oxygen in air, is necessary for combustion to occur. What is it? Air, or more specifically the oxygen. Why did we mention like this? It is because usually we say just air is needed for combustion, but if you have to be more particular as what in air is important, then we say oxygen, right? Always you should understand that combustion needs oxygen. Without oxygen there is no combustion, right? So oxygen is very important for combustion. Without oxygen the reaction cannot take place. However, not all substances catch fire at the same temperature. The lowest temperature at which a substance ignites and begins to burn is called as ignition temperature, right? So not all the substances catch fire at the same temperature. That you should understand here. This is a very important point, right? So the lowest temperature at which a substance ignites and begins to burn is known as its ignition temperature, right? So, and this ignition temperature differs from substance to substance. You cannot say that at this temperature every substance will burn, right? So it differs from substance to substance, and based on that the combustion will take place, right? If the temperature of a combustible material is kept below this point, it will not catch fire, right? It's obvious. This is the lowest temperature at which a substance ignites. So if you place that particular combustible material at a point below that ignition temperature, it will not catch fire. As simple as that, right? So what are the important things that we have learned here? We have learned about the combustion, and then about the combustible substances, and we now know that without oxygen there can't be any combustion, and we have also gained some insights and knowledge about ignition temperature, and we also know that the substances won't catch fire at the same temperature, right? Some substances have a very low ignition temperature and can catch fire easily with just a small flame, right? So some substances have a very low ignition temperature and these can just catch fire easily. And these are called as what? These are called as inflammable substances. Examples include petrol, alcohol and LPG. Because they ignite so readily, they must be handled with great care, right? We all keep hearing that you have to be very careful while you are using petrol, LPG, alcohol and all that, right? Why is it? It is because it will catch flame so easily because of its very low ignition temperature, right? So then, interestingly, the heat and light produced by the sun do not result from combustion. So, in the previous slide, while we were learning about combustion, what did we say? Combustion will give us heat, and also in most of the cases, light is produced. Now that sun also give us heat and light, so do you think that it is because of the combustion? No, it is because of the nuclear reaction that occurs in the sun's core. right? So interestingly, the heat and light produced by the sun do not result from combustion, right? Do not result from combustion. Instead, they are the result of nuclear reactions occurring in the sun's core. These reactions are entirely different from the chemical combustion, though both produce energy. When trying to put out a fire, it is essential to understand what keeps it going, right? So when there is a fire, you'll have to first understand as how the fire is being sustained, or is it staying. Only then you can understand as how, you will know as how to put off the fire, right? So three things are required for fire. What are those three things? As you all know, fuel. It is the combustible material, right? So the material that burns. Then what you need? Air. Air means, what did I mention? More specifically, what we need? We need oxygen. And what else? We need heat. Why? Because to raise the fuel to its ignition temperature. We have dealt with ignition temperature. We know that air is important. We also know that the combustible material should be there for the combustion to take place, right? So removing any one of these three elements will stop the fire. So you can either choose to stop the flow of oxygen, or you can reduce the heat, or you can shut or take off the combustible substance. Whatever can be done, you have to do in order to put off the fire, right? So based on this principle, the fire extinguishers work, right? This is how fire extinguishers work. They either cool down the burning material to below its ignition temperature, or cut off the supply of air, or do the both, right? Water is a common and effective method for controlling fire. It cools the combustible material, reducing its temperature below the ignition point, and also forms water vapor which surrounds the material and cuts off its oxygen supply. This dual action helps in effectively extinguishing the fire and preventing it from spreading. So what happens here? Water, you all know, right? Whenever there is a fire, the fire brigade will bring the water, and they will just put it on the fire. So why is that done? It is because it cools the combustible material. As you all know, the temperature should be maintained below the ignition temperature, right? Only then the fire will stop. This is one of the case if we are talking about the temperature. And the other way is, you will have to stop the supply of oxygen. So both things can happen with this water. First thing, it cools the combustible material, reducing its temperature below the ignition point, and also it forms the water vapor which surrounds the material and cuts off its oxygen supply. This dual action helps in what? It helps in effectively extinguishing the fire and preventing it from spreading. Alright, then what next? The most commonly used fire extinguisher is water, but it is effective only in certain types of fires, mainly those involving materials like wood, paper, or cloth. Why are we saying this? Do you think water is effective in extinguishing fire in all the cases? Do you really think that we can put off the fire that comes from some electrical device through by using the water? No, right? It's obvious. We keep on saying that you should not like put wet hands on the switches and all that. But even then, thinking that water can be used to put off the fire that comes from electrical devices is not right, right? So what is the other way that we can go with it? It is that water should never be used on fires caused by the electrical equipment, as it can conduct electricity and pose a serious risk of electric shock to anyone trying to put out the fire. Similarly, water is not suitable for fires involving oil or petrol. So, water is not suitable for the fires caused due to the electrical equipment, and it is also not good to use, or is not appropriate to use in the case of the fires involving oil and petrol. Why? Why with regard to oil and petrol? We have already mentioned about the electrical equipment, why we cannot use water, and why, how come that we cannot use water for oil and petrol? This is because water is heavier than oil. So it sinks below the burning oil, allowing the oil to stay on the surface and continue burning, right? So you need something to actually cover the combustible material so that the oxygen won't reach the material. But what's happening here, as water is heavier than oil, water gets down and the oil will be floating and it will have nice supply of oxygen as usual, and it keeps on burning. So it is useless to use water when the fire has come because of the oil or petrol, right? Then for fires involving electrical equipment or inflammable substances like petrol, carbon dioxide is the most effective fire extinguisher. So, when the fire is because of the electrical equipment or something like petrol, then you will have to use carbon dioxide, and it is considered to be the most effective fire extinguisher. And how will we get this carbon dioxide? Like water we know, right? Where you can find water everywhere and you know about it. Then how come carbon dioxide? How can you carry carbon dioxide? For that, carbon dioxide can be stored under high pressure as a liquid in metal cylinders. You all know fire extinguishers, right? The red bottle type things, right? It has carbon dioxide in it. When released from the cylinder, it expands rapidly, turning into a gas. So while inside it will be stored as a liquid, and while it's coming out, it rapidly expands into a gas. This expansion cools down the surroundings and displaces oxygen by forming a thick blanket of gas over the fire, right? As a result, the supply of oxygen is cut off and the temperature of the burning material is lowered, which helps to extinguish the fire efficiently. So, it is enough for you to understand that carbon dioxide is used for the fires involving electrical equipment or any petrol or oil types of things, right? And how the carbon dioxide is stored? It is stored under high pressure as a liquid in metal cylinders, and when it is released, it comes out, it expands rapidly, and it turns into gas, and it will form a blanket and it will cut off the supply of oxygen. Overall, the temperature of the burning material is also lowered, and so the fire gets extinguished efficiently, right? Now, another way to produce carbon dioxide near a fire is by using dry chemical powders like sodium carbonate or potassium bicarbonate, right? So, when you don't have carbon dioxide with you, right? So you may even use sodium bicarbonate. The usual name is baking soda or potassium bicarbonate, right? When these substances are released onto fire, they undergo a chemical reaction that releases carbon dioxide gas. This gas acts in the same way, cutting off oxygen and cooling the burning material, making it an effective method for controlling fires involving flammable liquids or electrical equipment, right? So at times when you don't have carbon dioxide with you, you may use sodium bicarbonate or potassium bicarbonate, and sodium bicarbonate is also called as baking soda, and when these substances are released onto fire, they undergo a chemical reaction that releases carbon dioxide gas. So overall, our aim is to use carbon dioxide gas to put off the fire, right? Only then you can do two things. What is that? You can cut off the supply of oxygen. O2 means oxygen, right? Oxygen. And the second thing is you can cool the burning material so that it will get to a point of lesser than its ignition temperature, right? There are different types of combustion based on how substances burn. In rapid combustion, a substance burns quickly and produces heat and light, as seen when a gas like LPG is ignited. Another type is spontaneous combustion, where certain materials catch fire on their own without any visible external source of heat or flame. For instance, phosphorus can catch fire at room temperature just being exposed to air. The sudden catching of fire without a clear cause is what defines the spontaneous combustion. So there are different types of combustion like rapid combustion and spontaneous combustion. Rapid combustion, a substance burns quickly and produces heat and light as seen when a gas like LPG is ignited. When you just put a matchstick near the this one LPG gas, automatically what happens? It will burn, right? It will give us heat and light. But when you don't actually give any source, like any external source of heat or flame, even then some substances catch fire on their own under certain circumstances. This is called as what? Spontaneous combustion, right? And for instance, what is it? Phosphorus can catch fire at room temperature just by being exposed to air. See how dangerous it is, right? The sudden catching of fire without a clear cause is what defines the spontaneous combustion, right? Whether or not a flame is produced during the combustion depends on the nature of the substance. So, in some material, in some substances like what do you call candle, take candle, you get a flame. But take coal, do you think combustion is occurring with a flame? Can you see any flame while you see the coal to be in action? No, right? So if there is flame or not, it depends upon the nature of the substance. Substances that vaporize while burning usually produce a flame. For example, liquids like kerosene oil or molten wax get drawn up through a wick, vaporize, and then burn with a visible flame. So substances that vaporize while burning will give you a flame. In contrast, substances like charcoal do not vaporize when they burn. So they produce no flame, only a glowing red surface. The presence or absence of flame thus depends on whether the fuel forms vapors during the combustion. So this is very important. If the fuel forms vapor, then what you will get? You will get a flame. And if not, then you won't get a flame. You can just see some glowing red surface, right? What are the examples of this? Kerosene oil or molten wax, you get a flame, and for charcoal you won't get a flame. And you also now know about rapid combustion and spontaneous combustion, right? So now let us learn about the structure of the flame, right? So what is it? This outer part is called as the hottest part, right? Outer zone of complete combustion, it will be blue in color. And this is the inner part is moderately hot. And this is the middle zone of partial combustion, and it will be yellow in color. The least hot part would be this one, this inner part, innermost zone of unburnt wax vapors. It is black in color, right? So this is least hot, moderately hot, and hottest part, right? When a candle burns, it produces a flame that has a well-defined structure divided into three main zones. Each zone has different characteristics in terms of color, temperature, and the kind of reactions taking place. The innermost zone of the flame is dark or black. As I have mentioned, this is dark or black. This part is the least hot and contains unburnt wax vapors, as there is not enough oxygen for combustion here. As I have mentioned, with oxygen the combustion will take place. Better the oxygen, better the combustion, right? So as there will not be much of oxygen at this point, this part will be least hot and you can find many unburnt wax vapors. Next comes the middle zone, which appears yellow and bright. It is the most luminous part of the flame and is moderately hot. In this zone, incomplete combustion takes place due to limited oxygen, and tiny carbon particles get heated up and glow, giving the flame its yellow color. This is why this part of the flame is bright and visible, right? Then the outermost zone of the flame is blue and is the hottest part. Here there is complete combustion because this zone is in direct contact with air and gets plenty of oxygen. Although it is hottest, it is not as bright as the yellow zone, right? So if this is the structure, this outer part will be the hottest, right? And the middle part, which is bright yellow in color, is medium hot. And near the wick, okay, this area is dark in color and it is least hot, right? It all this variation of temperature is because of what? It is because of the supply of oxygen. Now you can understand how important oxygen is, right, in the process of combustion, right? Thus, a candle flame consists of three zones: the dark inner zone, the least hot, the bright yellow middle zone, luminous, moderately hot, and the blue outer zone, hottest, and where complete combustion occurs. So, here, what is fuel? You all know, right? In the first slide, we have defined about combustible substance, and we have even mentioned that fuels are also called as combustible substance. But in order to make it clear, and I don't want any confusion to get into your mind when the question is like what is a fuel, I have explicitly mentioned its definition here, right? So a fuel is any substance that produces heat and energy on combustion. These substances are used to perform various activities like cooking, heating, running vehicles, and generating electricity. All right? A good fuel should have certain desirable properties. It should be easily available and affordable. It should burn easily in air at a moderate rate and produce a large amount of heat. Moreover, it should not leave behind any harmful or undesirable residue such as smoke or ash after burning. However, there is probably no fuel that meets all these conditions perfectly. Therefore, the best fuel for a particular use is one that fulfills most of these requirements effectively. So, what is a good fuel? It should have some desirable properties. What are those properties? First thing, it should be easily available and it should be affordable, right? It should burn easily in air at a moderate rate and produce a large amount of heat, right? So, it should burn efficiently in the air, and the heat, the output that you get should be large amount, right? Moreover, it should not leave behind any harmful or undesirable residues. See, our wants are too many, right? We don't want even that to leave any harmful or undesirable residues such as smoke or ash after burning. However, you all know that there is no such fuel which is best or ideal, right? You have to choose between your need, like based on your needs, you have to choose which one suits you better, because every type of fuel has different type of properties. Some will burn easily and give large amount of heat, but they leave behind harmful residues. Some will not be efficient, like they won't give much amount of heat, and uh, might not give any harmful residue, and some will be costly, but they might not leave harmful or undesirable residues. So it all depends upon the type of fuel, and so based upon your use you choose it, right? The amount of heat energy produced when 1 kg of a fuel is burned completely is called its calorific value. It is a measure of how much energy a fuel can provide and is expressed in kilojoules per kg. Fuels with higher calorific values are more efficient as they release more energy per unit mass, right? So what is it? We have here mentioned about calorific value, which is very important, and also about the units of how it is measured. The amount of heat energy produced when 1 kg of fuel, so 1 kg of something you take, like 1 kg of coal or anything of 1 kg you take, and if it is burnt, then the amount of heat energy that is produced, right, it is called as what? Calorific value. It is a measure of how much energy a fuel can provide and is expressed in kilojoules per kg. So how do you know the efficiency of any fuel that is being burnt, right? You can know based on its calorific value, right? So if we take 1 kg of few number of fuels and you actually burn it, like you will allow it to get to combustion, then if you check the amount of heat energy that is produced, and by comparing the heat energy that is being produced by different types of fuels, you will come to know as which is considered to be the most efficient fuel. Okay, in terms of the heat production, not in terms of everything. As I have mentioned, what are the other things about the harmful residues that will be given, and about the availability, about the affordability, these are all there, but we are talking only about the amount of heat energy, right? And this one is so important. This, it is a measure of how much energy a fuel can provide and is expressed in kilojoules per kg, right? Kilojoules per kg. This is very important. Okay, fuels with higher calorific values are more efficient as they release more energy per unit mass, right? Now, environmental impact of burning fuels. We have mentioned about the residues, right? Which may leave dangerous residues and all that. Why we always be very careful or very skeptical about burning the fuels? We keep saying that we should use less amount of fuels and all that. There will be some reasons behind that, right? There will be so much of environmental impact of burning fuels. There will be like human impact, like it will even impact the health of the human. So you will have to consider all these things while using the fuels, and you should also think about the sustainability aspects while using these fuels. For this very reason, you have to be mindful while using these fuels, and we will even now see as what is the impact of burning fuels on the environment, right? So the combustion of fuels have several harmful effects on the environment and human health. Below are the major concerns. What are those? Air pollution from unburnt carbon particles. Carbon-based fuels like wood, coal and petroleum release unburnt carbon particles during combustion. These fine particles act as dangerous air pollutants and can cause serious respiratory diseases such as asthma, right? So what are those? Air pollution from unburnt carbon particles. So carbon based fuels like wood, coal and petroleum release unburnt carbon particles during combustion. We have already dealt with this, right? That during the combustion there will be some unburnt carbon particles. These fine particles act as dangerous air pollutants and can cause serious respiratory diseases such as asthma, right? Then, toxic carbon monoxide from incomplete combustion. When fuels burn incompletely, they produce carbon monoxide, a highly poisonous gas. Burning coal in a closed room is especially dangerous due to the risk of carbon dioxide buildup, which can be fatal, right? So when the fuels are burnt incompletely, then you will get they'll get to produce the carbon monoxide, and it is a highly toxic gas, poisonous gas, and within few minutes it will pose like it will risk the life of the human, right? So carbon dioxide and global warming, you all know about this, right? The risk of global warming, like what happens because of the global warming, and how does carbon dioxide contribute to global warming. I know that you all are aware of all this. So most fuels release carbon dioxide upon combustion. An increase in atmospheric carbon dioxide levels is a major cause of global warming. Global warming refers to the rise in Earth's atmospheric temperature, leading to melting of polar glaciers, rising sea levels, floods in coastal regions, and possible submergence of low-lying areas. Now, these points are important, not only for this particular subject but for other subjects too, right? Even in social studies, this can be asked, and for the general awareness things this can be asked. So it's very important to actually understand these concepts of why this melting of polar glaciers occur, what is this rising sea levels, floods in the coastal regions, possible submergence of low-lying. What are all these with regard to the global warming? If at all you want an exclusive video on this, let me know in the comments. I will get a video on this too, right? Because it's very important that you understand these concepts and be aware of all this, right? So next, acid rain from sulfur and nitrogen compounds. Burning coal and diesel releases sulfur dioxide, a suffocating and corrosive gas. Petrol engines emit dioxides of nitrogen. These gases dissolve in rainwater and form acid rain, which damages the crops, buildings and soil and harms aquatic life and ecosystems. Right? You know about the acid rain, and you know as how oxides of nitrogen will get into acid rain and uh, will damage the crops, buildings, soil and everything. And you know, even our Taj Mahal is getting affected because of this um acid rains, right? So burning coal and diesel release sulfur dioxide, a suffocating and corrosive gas, and petrol engines emit oxides of nitrogen. So oxides of nitrogen and sulfur together will give us acid rain, and it will, what will it do? It will damage our crops, buildings, soil and also aquatic life and other ecosystems, right? So what is the way around? The way around is using cleaner alternatives like use of CNG. To reduce harmful emissions, compressed natural gas is being used as a cleaner alternative to petrol and diesel. CNG burns more cleanly and releases much smaller amounts of harmful gases, making it a more eco-friendly fuel. All right. As I have promised to you, I'm done with the chapter in almost 30 minutes. Like I have explained it. So 2 minutes here and there is fine, right? So you gave me your 30 minutes. I am here with my promise. Hopefully I have made it clear. I think you can now very well write any answer about this combustion and flames, right? Okay, if you are happy with the video, consider subscribing, right? Okay, see you, bye in the next video.